expression that's almost completely factored. If you'll notice this left-hand side, you can think of it as a single term. Notice that this part right here is almost a multiple of this piece right here. That is, if we take u to be this very first parenthetical quantity, notice that 5u is equal to almost the second factor there. It's equal to 5x squared plus 35x plus 55. Okay, so you see it's almost, but you know, it's not quite where we want it to be. Okay, so again, we have a 35 right here, we have a 47 here. But still, if we try this substitution, notice what we end up with. Okay, and it's pretty clear to see, based on this, we need to add 12x. Since 5u is actually equal to 5x squared plus 35x plus 55, we add 12x to 5u and we'll get the 47 that you see right here. Isn't that nice? Okay. Now we're going, okay, is that nice? Well, is it really? Well, only if the expression that we get factors. Now let's take a look and see if it does. Okay. So our original has been reduced to this expression that depends on both u, our substitution, and still has x's in it. Okay. Now when you multiply this out, you'll get what I've written down here. So let's check out and see if it factors. And of course it does. These problems wouldn't be any fun if they didn't. Okay, but if you go with the only try here, 5u, and let's just, we know we have to have at least this going on, right? Okay, if it's going to factor nicely over the integers or the rational numbers, I guess, this has to be the first term. This has to be the second term in the two sets of parentheses. Now we need things to combine in a fashion that will give us a 12ux. Well, that'll happen precisely if we put 3x right here and minus 3x right here, and that's easy to verify. Right, folks, if you multiply everything out, this minus 3xu right here combined with this 15xu gives you the 12xu you see in the middle. So you see we factored it. This is factored. And that's good news, except we still need to write it in terms of x only. So it is factored. So we're, in some sense, we're done with the problem, but let's write it. We were asked a question in Spanish, so we'll answer it in Spanish, right? So let's take a look at what our substitution was. U is, yeah, there it is. U is this object right here, x squared plus 7x plus 12. And so this would equal to, okay, 5u minus 3x, right, would be equal to, let's write down 5x squared. And again, y'all, what am I doing? I'm just, this is factored, okay? This is factored, but we want to get it in terms of x. So 5 times u is 5x squared, 5 times 7 is 35, but we have minus 3x here, right? So this will be plus 32x. See, y'all, isn't that neat how this works out? So that's 32x. And again, 5u is, put a 55 right here, so we'll have plus 55. Okay, like that. Okay, now our second piece right here would be u plus 3x. And so that'll mean we just have to add 3x to 7x. So we'll end up with x squared plus 10x plus 11. And y'all, we've completely factored that weird looking thing that would have been impossible, you know, probably not impossible, I guess, but so this is our final answer right here. Now I never can keep these things on the same screen, but that is the final answer. Okay, and it's equal to this original expression, and it's kind of hard to tell. You know that you would have a constant of 55 times 11. What is that? 55 times 11, that would be your constant term, I guess. Okay, And that's what we have here too, right? 55 times 11 would be the constant term if you expanded this out. So we have good reason to believe that this is true. But anyway, I hope you enjoyed. The substitution works just fine here, even though at first glance you would go, no, not really, because you're off here on this linear term. But it ends up just being kind of a standard competition type problem where it's designed to work out nicely. So it's a problem worked backwards, basically. But anyway, hope you enjoyed.